All right, so I stopped my video and started a new one because I'm eventually going to draw a sine curve. And not that I can't draw one, but I wanted to draw a perfect one for you. And so here's what's going to happen. First thing I'm going to do is just give you some basic definition rules for derivatives of sine and cosine. I know you know there's more of them. We have other trig functions that there are derivatives for, but in this section, 3.2, we're only going to worry about sine and its derivative, which is cosine. And the derivative of cosine is negative sine. Okay, now some people say, why? And I will tell you why. And here's what I did on my last slide. I tried to draw a little like coordinate graph out and draw my sine curve on there. And I thought, you know what? It would just be easier if I just snap my fingers and one would appear. Oh, very Jedi-like of myself. Okay, so here is a sine curve, okay? And what I want to do is I want to think about derivatives on certain spots on sine, okay? And since this is red, I'm going to change this to blue. And so at 0, if I were to draw like the equation of a tangent line here, well, gosh, it's going to like pretty much be it's going to kind of go through it. It's going to look something like this. Okay, so, and if you look at that slope looks like it's about 1. All right, so here's what I'm going to do very slowly, and I'll see if I can pull this off. I'm going to graph its derivative. And I suppose it'd be wise of me just to make a blank graph and snap my fingers, but I'm not going to do that. This is going to be all natural. Okay, good enough. All right, so here's what I got. At 0, okay, I have to have a slope at 1. Okay, so this is my slope m equals 1. And at 0, at x equals 0, which is right here, I must have a slope at 1. And so I'm going to call this x. I'll call this sine of x, kind of like your f of x or y. This is going to be 0, and then this is going to be m, okay? M being the slope. This is basically my f prime of x, if assuming this is f of x. Okay, so at 0, my slope is 1. At pi over 2, let's take a look at what the slope is here. Well, this is a max, which means my slope is horizontal, okay, which means it should be 0. All right. At this next significant point, which is pi, you can see that my slope here, similar to the one I kind of had a little earlier. I tell you what, that was pretty good, except that edge right there. Okay, is, well, this looks like a slope of -1. So at pi, my slope is -1. And then at 2 pi, sorry, at 3 pi over 2, it looks like this slope here again is 0 because that's what a minimum is. So at 3 pi over 2, it's 0. And at 2 pi, which is at that spot, you can see that your slope is about 1 again. Okay, if you were to draw that. So at 2 pi, it's about 1. All right, and so look at what these 5 points do, and you can see that this increases at a decreasing rate. Okay, so sorry, that's the wrong spot. This has a slope that gets smaller and smaller and smaller. Notice that it starts at 1 and it gets closer and closer to 0. So that's what's happening here. Your slope, remember this is your height, is getting closer and closer to 0 as you get closer to pi over 2. Okay, and here it's 0, and then it becomes negative. Okay, and at this spot right here at pi is the largest negative that we have. Okay, which means that sounds weird to say. Absolute value-wise, it's the largest negative I have. It has the deepest minimum, if that makes sense. And that, of course, would be at this -1. Okay. and then it still goes negative. Okay, it's still in the negative location. However, it eventually will approach 0. So at 3 pi over 2, it'll eventually give you a slope of 0. And then again, these slopes here are positive. Okay, this is a increasing function there, and then it becomes positive again. And so that's why your sine curve, the derivative of that is a cosine, and then it would keep going over and over with further oscillations. Okay. All right, hopefully that explanation made sense. I can easily just tell it to you and have you memorize this, and I know you're smart enough to do it, but sometimes it's important to know why. Okay, I will not ask you to draw this. Okay, this is just for your knowledge. All right, derivative of e dx. This is my favorite function. The derivative of e dx, you will probably remember, is just e dx. It's itself. All right, so if I were to take the derivative of f of x, again, the derivative of e dx is e dx. Okay, the 6 out front is insignificant, so just leave it as it is. Okay, and now we have work from the past. Okay, the derivative of 2x, this is really 2x to the first, so we'll bring the 1 down. 2 times 1 is 2. And when you subtract 1 to this, you'll get x to the 0 power, and anything to the 0 power is 1. And since I'm just going to multiply this by 1, I'm not really going to even write it. Okay. And then finally, the derivative of sine, we just said was cosine, and we verified that. And there is nothing else to do. Just make sure you got this little prime sign here, and you are good to go. Ooh, instantaneous and average rates. Average rate of change. So here's what we got. It's really not that bad. It says a piece of gum is dropped from a height of 200 feet. The gum's height, s, that sounds weird, but yeah, the height is s, at time t seconds, is the position function. S is equal to negative 16t squared plus 200. Okay, it says find the average velocity. You see these all the time on AP exams. Okay, and the part that makes this difficult for average velocity is that it doesn't really involve new material. Okay, it's over stuff that you've done in previous math classes. In fact, there's no pure calculus for this. Okay, it's kind of a fundamental piece of it, and that's just taking the slope. Okay, so here's what you're going to do. You're just going to find the slope between the boundaries 1 and 2. Okay, so my function is of s. So I'm going to take s of 2 minus s of 1 all over 2 minus 1. Okay, so slope formula, that is it. This is sometimes an AP question. You know, they'll give you a question like this for a free response, and it'll be a part A, and people think there has to be some fancy calculus piece to it, like some type of derivative, and there's not. It's just a simple slope problem. Okay, so, all right, so my s of 2 means we're going to take negative 16 times 2 squared and add 200 to it. Okay. Minus, and then we're going to do s of 1, which means we're going to input 1 into all this. Okay, and I can put this all over, well, 2 minus 1 is 1, but I'm not going to write a 1 in the denominator. And so if you do this piece, and then the second one, okay, and subtract those two, you'll get your answer. Okay, so this will be negative 16 times 4 is negative 64. Okay, plus that 200. Okay, minus, sorry, I forgot my 0. Negative 16, because 1 squared is 1, times negative 16, it looks like 184. Okay, that's what would be in these brackets. All right, and so if you do this math here, let's see, negative 64 plus 200 is 136, and that would be positive, minus 184. And so let's see, let's just subtract this real quick over here. I don't have a calculator in front of me, so negative 48. And I'm going to put this in the proper units. This is a slope, and it is a rate, and we're talking about feet per second. Okay, now what does that mean? That means that this gumball drop is dropping at an average rate of 15 feet per second. Sometimes it's a little bit faster, sometimes it's a little bit slower, okay, between this 1 and 2. Okay, but on average, between that 1 and 2, all the collective velocities that you would have between these two boundaries would be negative 48 feet per second. Okay. Now that is very different from the instantaneous rate of change. And notice that this has 2 values. Okay, this one only has 1. Okay, and basically what this is saying, okay, is a super fancy way of saying is find the derivative at x equals 1. Okay, instantaneous rate of change means, okay, I'm just going to draw this little picture up here because that's your gumball drop. Okay, is that at 1 second, tell me how fast you're going. What is that slope? Okay, and I can already tell you it's negative, but what we'll do is we'll look at s. S is equal to negative 16. I don't really need that parenthesis, I just wrote it there. T squared plus 200. Maybe I'll erase it. Okay. And what we'll do is we'll take a derivative because that's what instantaneous rate of change means. You're going to take a derivative. All right, so let's do s prime equals, and negative 16 times 2 is negative 32. T, okay, plus 200. Now remember, if you have a plus 200 and there's no value here, that means this will go away and will not be part of your answer when you take that derivative. Okay. And now your s prime of this value 1, you're just going to plug that in. Okay, and that does give you negative 32. Okay, and you'll put it in the correct units, negative 32 feet per second. Okay, so at this respective location, where's my guy? Okay, good. Right here. At that point, at exactly 1 second, the speed of the gumball is dropping at 32 feet per second. All right, hey, this is the last one. I'm a huge wrestling fan, and Hulk Hogan was the wrestler at the time who was a superstar. And here's what it says. It says at time t equals 0, Hulk Hogan leaps from the top of a 32-foot steel cage and lands on top of an opposing player. Hulk's initial velocity was 16 feet per second. Okay? And his position, s of t, okay, remember we were originally making position be your s term, is equal to negative 16t squared plus your initial velocity, v sub 0 t, plus your initial height, okay? And so first question is, when does Hulk touch the ground? Well, let's first input values for my v sub 0 and my s sub 0. And conveniently, they're written right here. It's 32 is your initial velocity, sorry, your initial height, and 16 is your initial velocity. So I'm going to make this look a little more complete by putting in my v sub 0, which is 16 feet per second. Okay, so that will go here for your 16. And your last thing is your s sub 0, which is that guy, 32. Okay, now when does Hulk hit the ground? Well, when you hit the ground, what that means is you have a height of 0. Okay, and think about what our variables mean. T stands for time in seconds, which is what they shared. Okay, and let's see, s of t is your position, okay, in terms of a height. Okay, so when you hit the ground, okay, what that means is your s of t is equal to 0. Okay, and so you'll put a 0 here. Now, instinctively, what people like to do is put this in their graphing calculator and draw it, then do a calculate feature. Okay, do second trace, and again, you'll put this in Y1 just in case you want to know, and you'll do calc. And I think the second item is your 0. So get rid of that. New color, purple. Okay, so again, you would hit calc, and oh, geez. and then you'll do 2, which is 0. Okay, and that'll help you find out exactly where it crosses. Make sure you round to 3 place values. Values after the decimal, meaning to the right. Okay, so, but sometimes it's just easier to do it otherwise, okay? I don't know how long it's going to take you to put that in your calculator and then eventually do the step, but think about this. Do these all have something in common? Yes, they all have a 16 in common. In fact, I'm going to pull out a negative 16 to make it look a little cleaner for me. If I pull out a negative 16, I just get t squared. If I pull out a negative 16, I get a negative t, or subtract t. And if I pull out another subtraction sign, I'll get a subtract 2. And you can divide both sides by that negative 16 if you want. But this does factor. This is t minus 2 and t plus 1. We got to be careful of those. Divide by negative 16 to both sides. And so 0 is equal to t minus 2 and t plus 1. And so you get t is equal to 2 and negative 1. And in this particular case, I'm not going to put the negative 1 there because that's negative time, which only happens when you are Marty McFly, when you have a DeLorean. Okay, but my t equals 2 is when Hulk will hit the ground. So after 2 seconds from flying in the air, he'll crush someone. Okay, what is the Hulk's velocity on impact? Okay, meaning when he hits the ground, how fast is he hitting the ground? All right, now velocity, just so you know, is the derivative of your position. So let me write this over here. If this is your position, okay, then the derivative of your position is your velocity. Okay, and if you want to take it another step, the derivative of the position, or the derivative of your velocity, is your, I know you know this because you either had this in another math class or maybe even a physics class, is your acceleration. Okay, and you can do another one if you wanted. Sorry. I think the next one's jerk. Okay, and then after that, there's snap and crackle and pop. So there's the next 4 if you want it. And yeah, they did name it after a cereal. Or maybe the cereal was named after pieces of a derivative, you know, which would be kind of odd, you know. Imagine if Tony the Tiger was really not Tony, it was really acceleration, just because that was a one of the many types of derivatives for a position function. Acceleration to Tiger just doesn't fly. I think they're just stuck with Tony. Okay, so here's what I gotta do. I gotta take the velocity of Hulk's position function. Okay, so let's just do s prime of t. Okay, and that is equal to, let's see, I'm gonna look at this part right here. I take the derivative of that is negative 32t. Okay. Now I gotta go, I was using this, but I actually gotta use this guy. That's my more complete one. Okay, and that is the derivative of 16t is 16. And the derivative of 32, this last item, is 0. Derivative of a constant is nothing. And what I need to do is plug in the time for when he hits the ground. And when does he hit the ground? Well, we said at 2. Okay, so you got negative 32 times 2 plus 16. Sorry. Here's what's happening. That is the ends. I cannot get rid of this. Darn it. Okay. So here's the good and the bad. The bad, you feel like this is less complete. You have it written down. Okay. You can rewind it and go see what it is, but I cannot on mine. Therefore, you can get the answer. If you left it in its unsimplified form, okay, which is negative 32 times 2 plus 16, I think. You can leave it like that and not simplify it if it's free response. That's okay on AP test, okay? All right, that's the last item. I would go back and give you the assignment, but you'll have to rewind it to get it, or you can just look at the bottom of your note sheet. That has it there, okay? I'm gonna make one more video that talks about the proof, and if you wanna watch it, that's great. If you don't, that's fine too. It's really small, okay? All right, thank you for listening to my lesson. I will talk to you soon.